Okay, folks, today, using several methods of factoring. You know what? It should say just factoring completely. And we go through things in an order. And guys, we've been doing this all along. Every day I say, okay, what's the first thing that we ask ourselves? The first thing that we ask ourselves is there anything that goes into all of them? The second thing I ask is, how many terms does it have? 2? That might be the difference of 2 squares. 3, or it might be a perfect square trinomial. If it's not a perfect square trinomial, I may just be able to see there's nothing in front of the x, so I just factor the back number and get the pair that adds to the middle number. Right? If there is something in front of the x, I need to use the quadratic formula and just work backwards, and it gives me the factors. Okay? If a polynomial has 4 or more terms, well, that's what we did yesterday. If it has 4 or more terms, then we need to group them. It may be 2 and 2. It might be 1 and 3. Okay? Then, once we're done, we need to make sure that each binomial or trinomial factor is prime. I don't want to just factor once and then stop. Again, that's like saying, oh, good, 12 is 2 times 6. I'm done. You're not done. You need to keep factoring until you can't factor. Okay? Number 6 there says keep going until you have factored everything and it cannot factor anymore. And then the last thing here, it says check your work by multiplying the factors. We haven't been doing that as much. Okay? And that's okay. It's time consuming. But on a test or on a quiz, if you have time and you want to check your work, multiply it back out and see if you get what you started with. When I get 12 is 2 times 6, 2 times 3, and I write its prime factorization, if I want to know if I've got it right, we'll just multiply them back again. 2 times 2 is 4 times 3 equals 12. Oh, good, I did factor it right.
Good job, sir.
Thank you, sir. Okay. Now, let's see what we have down here at the bottom. I bet they're going to ask us to factor something. Oh, okay. We're going to do what we've been doing all along. All right, let me scoot this down a bit. Remember, if you're watching online, you can pause it and copy these down. These are questions that you should have been asking yourselves for 3 or 4 days now. Okay? Very first one. Let's go through this. Is there anything that I can pull out? Ellie.
You can pull out.
I always look for numbers first.
You can pull out a 4.
I can pull out a 4, but you know what? I've got this negative here, and I don't want that to be negative, so I'm going to pull out a negative 4.
Okay.
Can I pull out any variables, Libby?
You can pull out an n squared.
I can pull out n squared. Okay? So now I'm done. Now I need to see what do I have left inside here. Negative 4n squared times n squared gives me negative 4 n to the 4th. Negative 4n times negative 10n, or negative 4n squared times negative 10n, gives me positive 40n cubed. Okay? Negative 4n squared times positive 25 gives me negative 100n squared. All right, so now I've taken out what goes into all of them. I'm done with this for now. I'm just going to be carrying it down. Now I'm looking at the stuff inside here. Okay, now I start asking myself the questions again. How many terms are there, Koulis? 3. Can it be the difference of 2 squares? No. That has to have just 2 terms. Okay. Well, I know I'm going to have negative 4n squared, and now I'm going to try and factor it into these binomials. Okay? Is there anything in front of the n squared, Millie? No.
Yeah.
There is not. Good. So I'm going to write n and n. Because I know that. There's nothing in front of the n. I know I'm going to have an n in the front of both of these binomials. Now I'm going to factor 25 back here. Am I running down? We may have to come back. Let's see. 25 is 1 times 25 and 5 times 5. Wait, do I want the positive factors or do I want the negative factors, Libby? I want the negatives. Okay, and we're going to finish this one up on the next video because I'm running out of time on this one. Okay?